Today we are in the business of slaying this draconian number. This number scares off more students than any number ever created. And so I'm hoping that today, with the methods that I'm going to show you, this number will not be near as scary as it used to be. So we will slay the dragon together. And for students that are in my classroom right now, I am the dragon slayer. And all of my students in this classroom are my dragonlings. Dragonlings, yes, you are dragonlings. And dragonlings are assistant dragon slayers. And so on we go into the wild blue yonder. And, oh look, it's already smaller. It doesn't fill the screen anymore. Isn't that wonderful? And what do you think is underneath here? Oh, what could A be? No, it has to do with a number, a very specific number. Oh, yes, it's that guy, Avogadro. Yeah, we don't want to look at that too long. Okay, yeah. No. And yeah, you see, I can't let you see the, no, you can see the A long. That's okay. But, can't show that very long. All right, so going down, I am using rep part to make a little bit of fun of this terrible, awful word that's so long, representative particles. And what are representative particles? Just molecules or atoms. That's all. So get some of these letters and numbers and stuff that, are a little scary, a little less scary. So to summarize, a mole of rep parts is equal to an A of rep parts. You know, that one. Can't let you see that too long. I don't want you to look at it too long because I don't want to ruin your brains. That blue is tough. Anyway, moving on. The example, to put this into perspective, 1 mole of representative particles in this case is a mole of strontium atoms. And the A number, anybody know what that A number is? Avogadro, yes, the avocado man. No, he's not really. So we have 1 mole of strontium atoms is 1 Avogadro number of atoms of strontium. That's how you read that. Now, today's classwork will be done using this method of calculation that I'm going to show you today. So, here is my first classwork example. Actually, it's an example that I'm not necessarily interested in you copying because I want you to just watch it and learn from it. Okay? So in this problem, we're given moles. This is just like last night's homework, isn't it? Yeah, it is. And we're trying to find atoms. So let's see if we can make that not quite so awful. So I look here at how we set this up. Setting this up, I don't know if you've realized this yet, but the business of unit cancellation, which is what we're using here, do you know what the purpose of it is? Can anyone tell me what they think the purpose is? For unit cancellation, which is what we're doing here. See, I'm canceling out moles, and I'm canceling out magnesium, and moles and magnesium, and those 2 units of measure are now gone. They don't exist anymore because they canceled out. And now all I have left is 4.3 times the A number of atoms. Now, doesn't that set nicely? Doesn't that feel good? When I first did this, I thought, wow, that kind of makes my brain less irritated. And so now we take that and we give that our final number. Okay, and not the final number, but what this has set us up to do. We're multiplying 4.3 times the Avogadro number of atoms of magnesium. And so as we go down here, we've got 4.3 times 6.0 times 10 to the 23rd atoms of magnesium. This guy out of the way. There we go. And so that works out. 4.3 times 6.02 is 25.9 when we round to 3 sig figs, which is all you need to do in these problems. Okay, and that's atoms of magnesium. And when we change this back into scientific notation, then we have 2.59. Having moved the decimal to the left, we have to bump this guy up, and that makes 10 to the 24. How are we doing? Yeah? Okay, I would like one person from each group of 4 to take a picture of this screen. And I'm going to pause it so we can do that, and then we'll get started right back. Okay, we're getting some questions now, and the first question was, this A is taking the place of, yes, this 6.02 times 10 to the 23rd. Exactly. And that's the Avo number, right? So the Avogadro number. And now we're going to go on and see what happens when we're going the other way. This is moles to atoms, and now I want to go atoms to moles in this problem. Remember? Don't look too long. Can't let you see that very long. Okay, so there we are, 4.77 times 10 to the 19. And this is, we're supposed to find the moles of magnesium. So, like always, we put the given over 1, and now we have set up our calculation because we know whether we're dividing or multiplying the Avo number. So, we just have that A down there, and now we can substitute. You see, in algebra, you substitute all the time, don't you? Okay? So, here we're going to substitute for that number as we move on. And the 6.02 part of that, okay, you want to see it again? Okay, there it is, there it's gone. So the 4.77 came from here, and the 6.02 is coming from that. Okay? And now when we work those numbers out, the first thing that comes up is 0.792 because we're doing a division. We get a smaller number. Okay? Smaller than 1. And then we have to deal with the power of 10. And when we divide powers of 10, we subtract exponents. So what's the exponent of this going to be? 10 to the negative what? 4, absolutely. Okay, now I'm following the nice little path that Tyler DeWitt does when he does his videos. Okay, and that is to show you where the numbers are coming from. This guy, the result of this power of 10 being divided, is going in here for the power of 10, and over here we've got this guy being formed straight out of the answer from this division. And that will result, after we move the decimal back into scientific notation position, that is. And now we have 7.92 times 10 to the minus 5. Now wait a minute, when we move to the right, don't we have to make it a smaller number? Yeah. Oh, 10 to the minus 5 is smaller than 10 to the minus 4. Okay? So don't be fooled by this one. It's not a bigger exponent in the negative direction. It's a bigger exponent in the negative direction because it makes it a smaller number. Okay? If we move to the left, then the exponent has to get bigger, and that would go to 3. Absolute. Minus 3. Yes, absolutely. Good, Pearlie. That was a good check for understanding. All right. Now, put this classwork directly into your paper, onto your paper for tonight. Use lots of space. The following are your classwork problems for today, which you're going to do just before your homework. So here we go. Here's your first problem, and let's see how that solves out. On the tape, I'm not going to walk through it. I'm just going to show you the answer. So I'm going to stop right now in class, and you'll have a chance to work on it at home, and then check your answer against my answer. Okay, I've just been walking around the class, and most students seem to be getting the idea with this. And so what I'd like to do is just reveal it to you real quickly. This is set up as a straight multiply problem because moles is on the bottom, because it has to be to cancel the moles in the given. And since this is, that one, since this is that one, that's the number of atoms that equals 1 mole. And so we go down here, and this guy is the result of this multiplication, A, the 6.02 part of A, times the given. And this is just the power of 10 in the A number. And now they come down and join together. And after we take this guy and change the decimal back here, that means we're going to have to increase this by 1 number, and that's our 10 to the 24. Okay, so how many in the class got this correct? Got this answer? Great, terrific. And it seems to be a consensus that using the A and then substituting in that big number is much easier to deal with the calculation. Okay, here we go. This is your next one. I'm going to stop the recording so you can work it at home, like we're doing here in class, and then check after you finish working it. If you just go on, you won't learn anything. All you're going to see is the answer. Okay, remember, we're using this guy. Don't want to let you look at it too long. And now let's check you out, see how you did. We've got your given over 1 here. Okay, we have to use the power of 10 here. We don't have any choice. Whoa, 10 to the 20. Oh, no. 10, yeah, right, 10 to the 20. That's correct. Okay, so here we've got moles on the top because this is, what that equals. And then we have the A number, that guy. And now we get down here, and we have actually 2 problems. The number that we're all familiar with, and numbers that we're all familiar with in division and multiplication. And that comes out to this number. We've got this guy subtracting 23 from 20 because we're dividing. And that gives us 10 to the minus 3. And so when we come down here, this number is, I didn't put a little dot thing. So this guy is coming to here, and this guy is coming to here. Okay? And as we continue down, after we move the decimal over here, we have to change this to be a smaller number because moving the decimal to the right makes a smaller number. And smaller in negative exponents is a bigger exponent. But the value of the power of 10 is actually smaller. And that's it. That's how it works. Homework problems for tonight are just like the problems that you've been working. This is the new stuff that gets you ready for tonight's homework. So grams is going to go to moles, or moles are going to go to grams. We haven't done that yet. The right arrow is the grams to mole thing, and the left arrow is the moles to gram thing. So if you're given grams, you have to find moles. If you're given moles, you have to find grams. So in this little explanation, we are going to have a periodic table because it's going to be different for every single element and compound. Okay, different atoms and different molecules. Okay? The following problems are from tonight's homework, and you can copy those onto a clean sheet of paper. Use a lot of space. The more space you use, the better you'll understand your work. So let's go on, and let's look at 11A. Go ahead and run that problem. and then we'll check you out, see if you got it right. Okay? Use the same formatting and the same method. Oh, no, you don't have to use the same formatting. It's really different. So I'm going to do this for you. So you're going to see how very different this problem is. Isn't it easier? Wow. It's simply one multiplication or one division. That's it. You're done. Molar mass does the conversion. When I look up on the periodic table and I look at aluminum, which is element number 13. So element number 13 is aluminum. At the bottom of the box, I see 27.9 something. 9 and a number bigger than 5. So I'm rounding this to 3 sig figs. And so when you do the multiplication, you come out with this number, but you need to move it to scientific notation, which will be good for you to practice. And on this particular move, a lot of people are very unsure about this 10 to the 1, but that's 10. 10 to the 1 is 10. And if we have 10 to the 0, what is it? It's not 0. What is it? It's 1. Yeah. Okay, and that's all there is to this problem. Okay, so leave space for B, C, and D. I would say about half of your paper. Okay? Just use lots of space because you need a given and you need a find for each problem. So give yourself room. And then we'll do the first one in number 12. Okay, this is one of 3 problems that are all pretty much the same. Different numbers, that's all. Okay, here's 12A. And there's going to be 4 of these problems where we're taking grams to moles. And the molar mass is what does the conversion. So we look up at silver. Silver is number 47 on the periodic chart. And you'll see the number for silver is 107.9 on your radio dial. Oops, no, this is chemistry. I shouldn't say that. So 109.7 is silver, and now we have a division problem. That's all there is to it. So when we change this to scientific notation, we move the decimal 1 to the right, and that requires that we move it 1 to the left, and 10 to the minus 1 does the job. So this makes the number smaller, this makes a smaller number bigger. Yep. Or a bigger number smaller, I'm sorry. So you got 2.36 becoming, or was 0.326. And this is in moles of silver. And that's it, folks. That takes care of everything you need to know to do tonight's homework. I hope this is helpful to you.